Hello viewers, welcome to my YouTube channel. How are you? Hope you are doing well and definitely you are getting ready for your upcoming exams. So here I have come with another important topic to enlighten your preparation. My topic for today is action potential and conduction of nerve impulse. Actually, I experience students that they do not have clear concept about the way of nerve impulse, about the way of conduction of nerve impulse. So I think I must make a video on this topic. So here I am. Let's start. This is our nerve cell, that is neuron. This is the structural and functional unit of nervous system. Here today I am discussing about very important topic of nervous system. Okay, so this is neuron. The neuron is divided into two parts. The head portion is called the cyton and the tail part is called the axon. The impulse actually received by these dendrites. These hair-like structures are called the dendrites and this peak is called dendron. So dendrite receives the signal, the impulse, and then it is conducted by the axon and comes to the synaptic knob. So this is the neuron and the conduction is actually happen by different small parts of the neuron. I am elaborating this part in my next slide. Here this is the small portion of axon. This part is highlighted here. This is the membrane of the axon, that is called the axolemma, and this part is the outer side of the axolemma, and this part is the inner side. So this is this is inner side and this is outer side. The outer side region is called the extracellular region and this part is called the intracellular region. This part is intracellular region and the fluid inside the intracellular region is called the intracellular fluid, and the fluid inside the fluid at the outer portion is called the extracellular fluid. And here the axolemma is separating these two parts. In resting stage or in normal state, the outer portion of the membrane is positively charged, and the inner portion, that is in the inner side of the cell, is negatively charged. Actually, this is because the sodium ions are present at the outer side of the membrane, and at the inner side there are potassium ions are present, potassium ion K+. So now you definitely have a question that both the sides are positive ions are there, because outer side there is sodium ions and at the inner side there is potassium ion. But how the charge differences, that is outer positive and inner negative, is happening? This is because of the protein, because negatively charged proteins are there at the inner side of the membrane. That proteins actually makes the inner side negative. All the events I am telling you, that is in resting stage, in normal condition. In condition, in resting stage, a nerve has this type of charge separation, charge differences. At the outer side there is a sodium ions, at the inner side there is a potassium ion. Because of having in both the region positive ion, but the inner side showing the negativity because of the protein molecules, negatively charged protein molecules. These negatively charged protein molecules, look at the one thing that we know that positive and negative both are together forms the negativity. So here that is actually happening. Positive ions and negative ion both are together forms the negative ions. So the negativity is more here, and the positive negative ion or negativity is showing here at the inner side, and at the outer side, as there are sodium ions, so they are showing the positivity. So this is the charge separation or charge differences throughout the membrane at resting stage. This charge difference in both of the sides of the membrane is called the resting membrane potential. What is called? It is called resting membrane potential. And its value is minus 70 millivolt. Its value is minus 70 millivolt. That means negativity is more than the positivity. So this charge separation, charge differences is called the resting membrane potential. And that is actually the action potential. These differences in charge. These charge differences is occurred throughout the length of the axon. And that is called the action potential. That action potential helps the nerve impulse to conduct. Okay, I am coming in details. If we define action potential, then we can say that it is a change in electrical potential associated with passage of impulse. That is, these differences throughout the passage of the membrane. Okay, and this charge separation, charge differences actually happen by specific ion channels. Ion channels means there are some channels on the membrane. Suppose I am drawing here. This is a channel. This channel actually helps some certain ion to come inside the membrane and goes out of the membrane. And that the name of the channel is actually depends on the ion they are passing through. Suppose this channel helps the sodium ion to get entered in the intracellular fluid, then this channel would be sodium channel. If one channel that helps the potassium ion to get out of the membrane, then we call that channel as a potassium channel. And some channels are there, they are doing both of the functions. They are in one hand they are entering the potassium ion, and on other hand they are throwing the sodium ions outside the intercellular space. Intracellular space. So these are the ion channels that help to maintain the charge differences. So here is the steps of nerve impulse conduction. The whole conduction process actually follow these steps. First, there is a resting stage. Here on the resting stage, the axolemma, that membrane, at the outside of the membrane there is a sodium ions, that is positive ions, and also there are potassium ion inside the at the intercellular space inside the membrane. Okay, and also there is, along with the potassium ion, there are also negatively charged protein molecules. So these charge differences I have already explained you that is called the resting membrane potential. The value of the resting membrane potential is minus 70 millivolt. So this is the resting stage. Now what happened? After the resting stage, when the impulse come, actually conduction starts when the impulse come, the stimulus come. Okay, when the stimulus come, then after coming of the stimulus, the sodium channels open first. That is I am telling about the depolarization, the second step. First is the resting stage. The condition of the resting stage is like that. And then when impulse come on the nerve, then the sodium channels get opened, and that channel allow the sodium to get entered into this space, into the intracellular region. This channel pass the sodium inside the membrane. Okay, then there is already potassium ions are there. So the positive charge becoming high inside the membrane. Positive charge becoming high inside the membrane. If we put that data into the graph, then we can better understand. Here, on the resting stage, that potential difference is minus 70 millivolt. And then when the sodium ions get entered into the cell, then the positive ions get high, the rate of the positive ion, the value of the positive ion is increased. So the graph will be like that. Okay, and it comes up to plus 30. Then the potential difference become plus 30 at the stage of depolarization. At the stage of depolarization, what happened? Sodium ions get entered into the intracellular space and positivity increased, and that value goes up to plus 30. Here, look at the graph. The value comes up to the plus 30. Okay. Now, the third step is repolarization. What happened? When the sodiums are coming inside the membrane, then potassium thinks that I have to go outside, because if all the sodiums come inside, then there will be no positive charge, then potassium channels will open. So on the repolarization state, the potassium channel gets open, and that channel helps the potassium to get out of the membrane inside. From this inner side, the potassium ions get outside. Okay. When the potassium ions are getting outside, then the positivity will be decreased. So, here look at the graph. From the 70, that graph comes up to plus 30. Okay. Then, when the positive ions getting outside, the negativity will be increased. So, the graph will fall down. Okay, the graph will fall down. So that incident is happen in the repolarization, when the potassium ions are getting outside and the positivity becoming low and negativity becoming high. Okay, then the last step is the hyperpolarization. In hyperpolarization, what happened actually? I have skipped one thing, that as the negativity is becoming high and positivity becoming low, so the value comes up to minus 90. So for in the repolarization state, the potential difference become 90. It become more negative. At that point, minus 90. Okay, so here on the next stage, at the hyperpolarization state, what happened? At this stage, this stage is actually helps the membrane to come at the original state, that is on the resting stage. So what happened here? Now the sodium potassium Na plus K plus ATPase pump, sodium potassium ATPase pump. Okay, this pump will open. Now this channel, this pump, what they actually do, they transfers 3 sodium outside and 2 potassium inside. 3 sodium outside, that means 3 sodium ions are getting outward of the membrane, outside of the membrane, and 2 potassium ions are getting inside of the membrane, and both these things are happening at a time by these channels called sodium potassium ATPase pump. In that way, they try to set the membrane at its resting stage. Here, the potential difference, what was in the repolarization state minus 90 millivolt, that comes to minus 70 millivolt. That is actually the resting state, or its normal state of the nerve membrane, normal state of the axolemma, or normal state of the membrane. Okay. The same thing is happening for the next part of the membrane. I am showing you on my next slide. Look at this picture. This is the small part of the neuron. This one is the another part, and this one is the another part. Okay. So first we learned that this is the normal state, where the outer side was positive and inner side is negative. Okay. So from the resting stage, when the impulse come, the membrane become excited and the channels get open. When the channels get open, the sodium ions come inside the membrane and makes the positivity high. So here look at this picture. This is the depolarized state. After influx of the sodium ion, the inside membrane that becomes positive and outside become negative. Then what happened? For the next step, the another portion, the next part, actually the impulse is conducted throughout the membrane. Okay, whenever the impulse come from this portion to the next portion, then the depolarization is happening for the next part, and the previous part it becomes repolarized. What happened in repolarization? Repolarized neuron, their sodium get out of the membrane and potassium get entered into the membrane. So the negative charge become the inner side become negative and the outer side become positive. And the second part it become depolarized. And then for this next step, the second part become repolarized and the next part become depolarized. Okay, so in that way the impulses are conducted throughout the membrane. Impulses are travel in these small parts of the neuron, and then they are traveling at the till the end of the synaptic nerve. The impulse keep on traveling till the end of the synaptic knob. So these are all about the nerve impulse conduction. I hope you understand better. And if you like my video, then please give a like, share and subscribe my channel. If you are new in my channel, then don't forget to subscribe. Thank you for watching. We will meet soon with a new, very interesting and important topic. Till then, bye. Take care.